Hey guys, welcome to Outside Screwball. My name's Stan, and welcome to Screwy Tuesday number 33. This is Chuck's weekly show. I'm going to narrate you through it. First and foremost, we're going to, as some of you may know from checking in last week, Chuck got a new Holdridge Radii-Cutter, and that's going to cut, it's going to cut convex and concave radius, so we got to play with it here a little bit. And he was cutting out some blanks the other day, so let's go check in with Chuck. He's cutting some blanks to test the Radii-Cutter, and he's using his tailstock attachment. I think it's a Morse Taper 3, and it's the indexable tailstock attachment. So let's go take a look at him playing with that.
I'm going to make some blanks for the Holdridge radius ball turner. Do a couple of demonstrations with that. So I thought I'd make multiple blanks, and I've got the blanks just prepped. These are just a bunch of aluminum stubs that I have, and I've faced them. And so I've set up the turret tool post here in an effort to save time. Save time because I don't have to do a lot of tooling change out. Had a little time in setting the actual unit up. It's been sitting in the drawer, and good fun to bring it out. Not the greatest with the sense of the adapters I have in here, in the sense of lengths. If I was going to be doing this on a daily basis, of course everything would be much more tailored to use. But let's give it a run, see how she works. I'm going to run the lathe in back gear for the threading, even just for the speed. Speed's really too slow for the aluminum, but for what we're doing, it'll be fine. Here I'm looking to drill 700 thousandths deep. So I can just set the caliper I have on my tailstock, this guy back here for the depth. Slight chamfer. Good, let's thread. Reverse the lathe to back out. And there we have it, threaded part. Rinse and repeat and do some more. So just a quick discussion on the tailstock, turret tailstock. It's an Enco unit. These are 1-inch bores that it takes, and I've made some aluminum adapters that go into the bore to hold tools, and then I actually purchased this from Carl, my buddy, the tool, and then Ryan, IL Gopher, he had seen this in an earlier video that I did when I purchased it back in the day, and he sent me a bunch of slugs, not slugs, or tooling that was set up to be used. They're all 1-inch bores and have different diameters. This one has a tap holder in it. This one actually is a Morse Taper 2. So that was very nice of him to send those to me. And then the other thing I'm using is adapters. You might be able to see it right there. These are Holdridge, and they're drill bushings. And so the bore, the standard bore that I did in these were set up to hold these bushings so that I could interchange. I don't have a lot of them, and I've been looking to pick more up, but they're really handy. Okay, thought I'd just show you that real quick, and it's just a simple press of the lever to turn it. It locks in place. That little bit of rock is in the quill. If you lock the quill, of course, it doesn't move, but then you can't feed the quill. So once it bites, it sets into its center position. It's not a big deal. Okay, we have the blank drilled and tapped, and then I went over on the surface plate and just scribed me a line. I don't know if it's showing up there. And then just chucking these up and parting them off. So I'm coming up with my part off tool on that line. I've got the threaded side in, and we're good to go. And we'll part them off. You put the gear late in gear. Keep on going.
And we're back from that. And next up, we're going to talk about the hold-down clamps that were so popular. We'd like to give thanks to James Kilroy for sending out the email on a pretty smoking buy on some hold-down clamps, the Bridgeport style with the little brass covers on them. But here's Chuck showing those off after he got them in.
Well, I got some new tools in the shop. Little story behind these guys. I got an email from James Kilroy the other day, and I was copied there amongst other guys, Adam and Randy Richard and Stan and a few guys. James had found these on eBay, and the guy was asking 2 for $20. And said they were U.S. made and new stock, never been used, and you can see they haven't. And in the email, James had said that it was a best offer also. James offered $12, and he bought them at $12 for a pair. Well, in the same email, Randy Richard said, hey, I offered the guy $10, and he took it. So he bought $10 for a pair, and so I saw the email and I thought, what the hell? And so I sent the guy a note and said I offered him the $10, and he said yeah. So I bought 2 for $10 or 4 for 20. Heck of a buy. And I sent it on to a couple of guys. Sent it on to Ray Cornelia and another friend, Andrew Padaka. Well, Andrew wrote the guy, and Andrew got a best offer back at $13. And I think what was happening was, since we all got the email at the same time, we were all kind of hitting the guy at the same time with different things. So anyway, $20 for the 4 of them, including shipping. Sweet deal. Good quality. Got the brass on both sides. I do have 4 of these already. This is another product that I had. Brass only on the one side, and as you can see, the ones that I had were a little bigger, not much, but a little bigger. These were made in Japan. These were Japanese. I bought these on Craigslist off of some guy some time ago. But anyway, never can have enough of them. Really happy with the purchase and the price. You just can't beat it.
Okay, and we're back from that. And those are really nice looking clamps. Congratulations, Chuck. Chuck picked up 4 of those. I picked up 4 of those myself. I haven't been home to see them, but if they're anything like Chuck's, they're very fine pieces. And thanks again to James Kilroy for getting that email out and getting everybody hooked up with those. Next up, we're going to go and figure out how to set up the Holdridge cutter for a very specific radius. So Chuck and I read the instructions and we figured it out. The instructions were a little foggy, so we decided to come up with our own tutorial on that. And we shot a little bit of video, and this is how we determined you set the tool for the Holdridge. So take a look at this.
Well, as Stan mentioned, he and I, especially he did a tutorial on how to set this tool up, and I lost the file, or I goofed it up. So anyway, you're stuck with me doing a tutorial on it now. This is the instructions that come with the tool cutter itself, and it gives you tool setup and radii setup, and then it talks about the measuring methods. And you can read it a few times. It's a little confusing. I'm going to talk about doing a convex setup here. So basically there's some parts here to the tool. There's 2 machined flats right here, and from the machined flats to the center of the spindle is a 1/2 inch. They supply you with a setup bar for measuring, and it's a 1/2 inch parallel with a hole in it. And the purpose of the hole in it is that you can use a depth mic to set the distance. So this setup right here that I'm going to do right now would be for a 1 inch ball, which would be a 1/2 inch radius. So right now the depth mic is projecting beyond the bar 1 inch. So when we take the 1/2 inch from the face of the tool here to spindle center, that will leave us a 1/2 inch for the radius, and that's where the tool is set at right now. So if you wanted to go, you just have to take whatever your stick out is less a 1/2 inch is what your radius will be that you're going to cut to. So I hope that explains how to set it up. It seems a little more simple than the instructions. When you do set the tool up, they do give you some specific heights of what the tool is set for. And on my lathe here, which is a 14-inch closing, basically the tool was only out maybe less than 50 thousandths in height, and there's an adjustment screw underneath here which raises and lowers this piece to set your center height, so that your center and concentric with the center. If you'd either have to shim up or down, shim up if you had to over here, if you had a different lathe, or possibly mill this to bring it down if you didn't have it perfect for your own setup. But basically you set that height there, you set your distance, I'm sorry, and then you're going to bring this center point in to the center point here, lock the carriage, and then bring out the cross slide, and then you start making your passes to create a ball. Hope that helps.
And here, let me ask a question here. Magic 8 Ball, can Chuck get me a beer? It is in the cards. Thank you, Chuck. All right. Okay, and we're back from that. So that's how you set up for a was that convex? Yes, it's convex cut. Concave is when you're building up maybe like a shiv or something, or a pulley that has a rope drop in. Okay, so now we've set the tool and we want to play with it. Chuck's already got blanks cut out, 1 inch, so let's go get as close as we can to making a 1 inch ball out of a 1 inch part. If it runs eccentric at all, we're not going to get a full cut, but let's give it a try. Let's go see how we do with 1 inch. Okay, you're
All
live.
right,
You're live.
test number 1.
You're live.
We're not making it to center.
You don't want to go to center yet.
Yeah, if you're going to get a ball.
Let's see.
Oops, I didn't even close to touching it. We're not on center.
You're gonna be when we get. Oh, you say the carriage move?
No.
I'm on center there. I don't want to go too far. I'm going to smack your chuck there. That stop's going to change. The more I move the carriage in, the closer I'm going to get. I can spot it. It's going to hit right here. Got some WD. Is that going to splatter your camera? I'm still not getting all the way around where I need to be. I can see it where. Travidile is not working yet. Is this for X or Y? Get in any deeper than that.
See this? So I already did that.
That's how this is going to come out too. I'm just going off the tool in there. It's going to make a ball though. It's not going to be a 1 inch ball. If you're starting off with 1 inch material, I'd start off with like 1 1/8 or something big, so your final pass can be the whole thing. You're just happy you're cutting balls. You've got a ball fetish, I've got an angle fetish. How do I know when I'm coming up on my mark? I'm getting close.
And you traveled out?
Am I moving it at all?
Yeah. It moves double of what this guy moves.
Okay.
So you're about 15,000 still.
Okay. Yeah, it's going to cut any lips until you get it in to where you're dead center. Pliers, I can pull that shit out of there. that tip from what I'm doing there. You should probably make yourself some insert tooling for this. A little round with a flat on it that will take a little GPG.
They show it in their catalog.
Oh, okay.
Yeah. That's double.
Okay, so I want to be on
Zero.
Zero. This zero or the next one around?
Looks like,
I got 20 thousandths to go on that dial.
This zero. Yeah, so it's 40,000 still.
It's getting close, but it's still leaving that little pip mark there. I got it. I'm not gonna look at it. Contact there all the way around, so you should converge pretty good. Did you check this tool? Is it very sharp?
No, it's not very sharp.
Not very sharp. Still got the little pip in the middle because I'm still off center.
Far enough that we could go all the way to the 3 inch.
If you had a 5C set up on here with a nice heavy mandrel.
That's what I started making.
Yeah.
But this was just a test to put the balls in the sink.
That'll do it. I've only got about 5 thousandths left to go here. We'll do that on center here. I'm on zero here, but not there. And I'm cutting the pip. So you say turn to zero here. Still got 5 thousandths left on that. Which one am I trusting? I'm looking like zero here. But see, you've still got a little shade of it, not even all of it, that hasn't made it all the way. Something's getting on. A little bit more. If we can get it equal by equal, where we measure this way and it's the same, let's go beyond the 1 inch and see if we can do it. Because if your material was, we didn't have any machining allowance in there. Yeah, that tool is really dull. It's not letting me get finished. And I'm still not cleaning up. You still see the streak coming around. I'm going to go ahead and take it in just so I see a full cleanup, that way we can mic it. I got it. A little chatter there. Chattery on that. Actually, we leave it right here. Yeah, you see it bumpy as hell.
Let's do a hair of a cleanup.
Well, I was gonna spool it up. Is there any way for us to move away and get back to the same spot? Lock there.
Yes.
Shut it down. That was chattery as hell. I wanted to look at the tool.
It was hammered when in the set. That's the only one the guy had used.
Yeah. Wow. The tip's busted off. If you get yourself a magnifier and look at the tip's snapped off.
I lost my magnifier.
Here. Oh, those magnifiers.
Yeah. My buddy Chewy, when he was here, disappeared.
The very ragged end is busted off. It's plus it's neutral tooling. It'd be nice if it was.
It's not too bad.
It might be a little.
You want to look at it with that one?
Yeah. How strong are these? Oh shit, these are really strong. Now your tip's gone. You can see it right out there at the very point. Well, what it's doing is it's giving you essentially negative tooling. That tip is busted down like that, so it's kind of dragging. Yeah, I can see it with these. Yeah, we're not going to get a great finish like that.
No.
I'm trying to think how we could speeding it up would do anything. A lot of it's the mandrel.
Right.
Well, that's just a bolt. But, yeah.
It's just a bolt coming.
Yeah, yeah.
It's just the first test of the whole thing.
Yeah,
how to do it.
That's fine. Let's get back to where we were.
Come on, Howie.
Okay. You were at just 0, 0?
Yes.
That put us right back where we were. Alright, go ahead and spool it up. Get this out of here. Alright, give me spindle. See if I can do any better here. An extra 3,000s. Just doing the lightest of, still chattering.
I think it chatters worse going that direction than the other.
Yeah. I don't think it, I think it's the actual cutting tool. Trying to make a fast cut, a slow cut. Trying to make it go away. Can you slow the RPM down?
Yeah.
Let's try that. We're going to go in another couple thou. That's 4 thousandths on the diameter. That's carbide, isn't it? Yeah. And then a carbide, yeah, it's still doing it. I don't think it's the Holdridge, I think it's just the cutting tool itself. But it's not even clean enough that they could mic it, I don't think. put my finger on there to dampen any vibration. It's better. It's not great, but it's better. But I bet if you mic it kind of diagonally and then this way, it's the same, whatever it is. It's going to be under your 1 inch that you were looking for. Oh, we can use this to get back to 0, right?
Yep.
I've never used a travidile.
Yeah.
So just put that on 0
and then put this other guy on 0.
Oh, where's the? Oh, I see it.
Then you end up 0, 0.
Do I pull up or something?
No, just turn it.
So I'm 0 by 0,
Yep.
and I unlock here, and I. Oh, that's bitching. Okay, now you got room to measure it, and I can get back to where I was. 982.
Mm-hmm.
You picked this up really cheap, didn't you?
Yeah.
How much was it?
Under 400. Three something. 981.
So how close is it diagonally?
Oh, across this way? Like
well,
this?
just we want to make sure we're equal, kind of that way, and then straight across, because we're getting a full cut.
982. Yeah.
So, but, I mean, so you're cutting a ball.
Yeah.
Okay. That's 91.5. So yeah, you're cutting round. That's the way you do it. And if you want to intentionally cut an elliptical, you can.
Yeah. So the problem I was having was with my setup. When I had the compound turned over to the side, because now this isn't on center anymore. The center point isn't on center, right?
Well,
does it matter?
Yeah, no matter what. Do an imaginary line, a string going through this, right? Through this pivot point and this pivot point.
Let's for the fun of it.
Pretend it's a laser or a string, whatever.
Yeah.
When you get to your final dimension, that string needs to be going straight through the part down the center line. After you've come in, that imaginary center line here needs to be going splitting that bolt and that ball right in half.
For shits and giggles, let's move the compound over.
All right, okay, and we're back from that. Results are pretty good. The tool needed a little bit of sharpening, and next up, the tool actually comes with a very specific sharpening fixture. And we needed to dress up the tool. So let's go take a look at what it takes to get that tool ground and how nicely the little grinding attachment works that comes with the Holdridge. Is that the stone that came on it?
The diamond wheel?
Yeah.
No.
Oh, you bought one?
Yeah.
So they come with just regular green
Two
wheels?
green wheels, yeah.
Oh, okay. Alright, we've converged out to the tip there and there. Now we got to do a little hand stoning and give that a little nose radius. And what we're making sure of is that the top grind here, this side grind, and this side grind have all three converged out at the point. We were chipped off before. So now we're going to put a nose radius on it and give us a little bit of diamond dressing, and we should be in good shape. That was that a 600 grit wheel?
I forget, I bought it a year ago.
Okay, but that's a finished grind, and that's what the tool provided. The two bottom surfaces here are of the proper degree. I don't know what that degree is, but it's of the proper degree.
20 degree.
There you go. You're like the shell answer man.
I read the book.
You read the book. All right. And so that grinds up pretty nice and easy. Next up, just for the heck of it, we're going to stay with the 1 inch blanks. This time we're going to cut a 2 inch ball, which is a 1 inch radius. So we're going to double our radius from ½ inch, and we're going to run it all the way out to 1 inch, and we're going to cut basically a 2 inch ball. But this time we're just going to check it with a radius gauge and see if our little setup's working with the depth mic and everything. So let's go have a look and see how that works out.
So here we got Stan. He's cutting a 2 inch radius, right?
Yes.
On the end of the 1 inch stub we have
2 inch diameter. It's a
2 inch diameter.
1 inch radius.
1 inch radius.
we've almost converged out to the diameter we have available.
And basically in feeding 10 thousandths a shot.
Yep. That's it.
Sweet. Go.
Okay, we got a 1-inch radius gauge here, and we're just going to check our tool back set and everything. I'm going to hold this piece of paper down behind it so you can look straight down. So he's going to bring the camera top down. I'm just going to bring that in there so you can see that we've got a nice fit. And the trick here is you got to hold it directly on center. If I go above or below, you're gonna get a bad reading. So you need the pip there in the center. You need to make sure that thing's going right across there. But I'm going to call that a success. That's a good accurate little radius there. All right, so the setting of the tool we know works. So good job, Chuck.
Good job,
Okay,
Stan.
so I think we got a winner. That thing came right in there. We held a piece of paper behind it, and the results were very good. I'd like to thank you guys for tuning in to Screwy Tuesday number 33. It's brought to you by Screwy Balls. If you don't own some, get some. Available at Chuck's eBay store. I thank you guys for watching. We'll see you next week.
Well, guys, in closing, I just want to say thank you very much to Stan. He visited my shop on Sunday. He's working up in the area, and I had just a great day spending time with him. I hope he enjoyed also. And he helped me out understanding how to use the radius cutter. I was having some difficulty getting my little brain wrapped around it, as you could tell during the videos. Stan's a good mentor and educator there. So again, Stan, thanks a lot, and you're invited back anytime while you're working up in the area. Definitely love to see you. All right, guys, hope you enjoyed. See you next Tuesday. Go, 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 get it, go.